Okay, gang, let's see if we can get this right this time. First, you got 2 packets. Pause the video after you're done with the first one and work on the assignment. Otherwise, it's going to be really overwhelming when you try to do them both at the same time. 20% of the land in the United States is covered by mountains. That there are 200,000 square miles in the United States, how much is covered by mountains? So we make a proportion, 100%. You're going to put 20%. Now you can't rely on that of, okay? That's not going to help you in an actual word problem. Instead, the part over the total, you want to define the part, okay? And I've circled how to define the part. It's covered by mountains. That's what makes a percent stand out. Covered by mountains. Now I'm going to reread the problem, and you tell me if that 200,000 square miles is covered by mountains. 20% of the land in the United States is covered by mountains. There are 200,000 square miles in the United States. How much is covered by mountains? Now those 200,000 were not covered by mountains. So 200,000 is going to be my total down here at the bottom. I'm trying to find the part that's covered by mountains because it asked me how much is covered by mountains. So I cross multiply and divide. I take 20 times 200,000 divided by 100. Okay, it's 40,000. So I put 40,000, and it has the same label as the 200,000 square miles, SQ miles, boom. I know that's a lot of square miles to cover by mountains, but it's all the land in the United States. Okay, 10% of the paycheck is spent on groceries. If I spend $300 of my paycheck on groceries, how much money is in my paycheck? Okay, so I go percent over 100%, and 10 is my percent. Okay, then over here you got your part over your total. Okay, so again, you want to define your part. Your part is defined by what's spent on groceries. Okay, now the $300, did you spend that on groceries? 10% of my paycheck spent on groceries. If I spend $300 of my paycheck on groceries, how much money is in my paycheck? Yes, it does say $300 was spent. I spent that on groceries, okay? If you read it, so that's your part. You have your part. You have to find how much total money is in your paycheck, so X. So I cross multiply and divide. So I take 100 times 300 divided by 10. That's 3,000. So $3,000. Okay, I can bench press 200% of my body weight. If I can bench press 500 pounds, what is my body weight? So again, your percent is given to you, 200, 100. Now, part over total. Okay, so your part is defined by your bench press. So if that 500 pounds doesn't represent what I can bench press, it goes down here. If it does, I put it up here. Now reread the problem. I can bench press 200% of my body weight. If I can bench press 500 pounds, okay, so I can bench press 500. So 500 is my part. What's my body weight? So I put X down there, and I have to find the total. So I multiply 100 times 500 divided by 200. $250. Okay, so 250 pounds. Okay, 45% of the trolls in the Magic Forest had happy faces. If there were 450 trolls in the Magic Forest, how many had happy faces? Okay. So you got 100% and 45%. Part over the total. Okay, the part is defined by those trolls. That's what makes them special, is that they're happy trolls. They had happy faces. Okay, did 450 trolls had happy faces? 45% of the trolls in the Magic Forest had happy faces. If there are 450 trolls in the Magic Forest, how many had happy faces? Now, the 450 trolls, that does not represent how many had happy faces, okay? So that is the total. That represents the total, and I have to find how many trolls had happy faces, so I cross multiply and divide. 45 times 450 divided by 100. 202.5, so we're going to put 203 because we don't want to cut any trolls in half, okay? 203 had happy faces. You have 450 total, and that accounts for 45%. A percent by definition is a ratio. You just don't see the 100, but you kind of put it there. Okay, 40% of the students in school dressed up for Spirit Day. If there are 300 students in school, how many dressed up for Spirit Day? So I have 40% and 100%. Now it's part over total. Okay, the part that defines the 40% is what dressed up for Spirit Day. Okay, and then, so I need to decide where to put the 300. Sometimes it's top, sometimes it's bottom. You got to read it. 40% of the students in school dressed up for Spirit Day. If there are 300 students in school, how many dressed up for Spirit Day? Now, you have 300 students, but they didn't all dress up for Spirit Day, so that's your total. Some of them did, some of them didn't. I have to find the part that dressed up for Spirit Day as they're asking me in the problem. So 40 times 300 divided by 100 is 120 students. Okay, next one. 60% of the roads in town need to be reconstructed. 180 roads need to be reconstructed. How many total roads are in town? Okay, so we got 100%, the 60% over it. Now, part over total, the part that's 60% is what needed to be reconstructed. So need to be reconstructed. Okay, now the 180, is that your total or is that how many need to be reconstructed? Now, if you read the problem, it'll tell you 60% of the roads in town need to be reconstructed. 180 roads need to be reconstructed. How many roads are in town? So X. So I take 100 times 180 divided by 60, 300. Okay, 300 roads. Pause the video and do the other problems, okay? And go rejoin me on the next part. Okay, next one. There are 500 stray cats in the town of Alta, Iowa. The amount is going to increase by 5%. How many cats will there be after the 5% increase? Now you notice I've underlined the word increase. That means you need to change your approach. You're not going to put 5% over 100 and go with part over total. That's not going to make any sense, okay? When you see the word increase, that's an addition by a percent. So what you're going to do, you can go off the side and you're going to take 100% plus 5%. Increase means add. That's 105%. Now this is the one instance where you need to make your percent into a decimal. You put the decimal at the end and move it twice. 1, 1, 2. Okay? So it gives me 1.05. So remember that. Now you're going to formulate an equation and you're going to put two factors multiplied by each other on this side. Though I'm going to put numbers in those spaces, and then it equals then the product. This is your percentage and you're going to put 1.05 in it, okay? not 105. You have to put, if you put a percent into an actual equation without a proportion, it needs to be in decimal form. Okay, and what you're going to put here is before, the cats we had before, and the cats we had after. Now, as you can see, the question's asking me how many cats will there be after the 5% increase. So I need to solve for the after. That's X. That means I must have the amount we had before, and that would be 500. Okay, now this is an easy one. 500 times 1.05 equals X. Okay, so you take 500 times 1.05, that gives you 525. Stray cats. And that makes sense. You got 500 before, increases 5%, and then you got 525 after. There's other ways to do that, but that's how I'm going to do it. A school's number of students decreases by 5%. Okay? If there are 600 students after the decrease, how many students will there be before? Okay, so I take 100%, and when you decrease it by 5%, decrease is underlined, you're going to minus 5%, and that's 95%. So you put the decimal at the end, move it once, twice, and I put a 0 in front. 0.95 is the percentage factor. So two factors multiplied together equal a third, a product. Okay, these are the factors, these are the product. The factors, second factor is your percent, which is 0.95. Then you have before and you have after. Now the question's asking me how many students were there before. So I put X in the before and 600 students is the after. Again, I circled the words before and after because that's what you're being asked to solve for. Okay, well this time I can't multiply because I don't know what that factor is. So to find a missing factor, you divide. And when you divide, you got to divide in the correct order. You put the product first, divided by the known factor. So I take 600 divided by 0.95. Now ignore that crap after the decimal and just put 632. So 632 is your answer. You had 632 students. There's a decrease of 5%. You end up with 600. Okay, makes sense. Basically, and that's gonna, when you're solving for the after, it's multiplication. When you're solving for the before, you have to divide. Do the opposite of multiplication. An item is marked up 15%. It costs $15.59 after the markup. What was the price before the markup? Okay, up 15. That insinuates that it's an increase in percent, so I add it. And that means the new is going to be 115% of what the old one was. So I move the decimal twice. That's 1.15. There's your percent factor. So with an, I want to write an, it's called the changing, the increase decrease percent equation. Okay. So you got two factors equal a product. Again, your percent is the second factor. It's 1.15. And then the first factor is what you had before, and the product is what you had after. Okay, I'm solving for before, so X is before, and I know it's $15.59 after the 15% markup. So again, to find out before, I can't multiply, so I divide, but when I divide, I got to do it in the correct order. Okay, you need to take your product of 1559 divided by your one factor, 1.15. Okay, now this is a money problem. When it's a money problem, you just take the first two digits after the decimal. If $13.55. Okay, if your answer is money, I want two numbers after the decimal. If it's not money, we'll go with a whole number. Okay, an item is 25% off its original price of $45. How much is it after the sale? So again, off means a decrease. So 100% minus 25% is 75%. So you move the decimal twice to the left, put the 0, and 0.75 is my percentage factor. All right, so again, I need to line up. So you're finding how much it is after, so that means X is over here, and the before you got 45 times your percent factor is 0.75. And you can just go ahead and multiply. 45 times 0.75, $33.75. Okay. 25%, 45 to begin with, 25% off, and so forth. Okay, two more. How about a textbook for $40? After I'm done with it, I can sell it for 12% more than what I bought it for. How much did I sell it after I was done? So again, more than insinuates an increase in percentage. So I take 100% plus 12%, that's 112. Move the decimal twice to the left. And I've got 1.12, okay, so equals, these are not ratios, okay, these are just blanks I set to put numbers on top. So by percentage factor, 1.12, before and after. Okay, so I'm solving for the after. That's what I don't know. So X and $40 is before. Okay, it's very easy to solve for X here. You just multiply the two factors on the other side. 40 times 1.12. Now again, it's a money problem, so I'm going to put 44.80. Money problems, I want to see two numbers after the decimal. $44.80. Okay, last one. Gas decreased in price by 5%. If the price after the decrease was $2.39, how much did gas cost before it decreased? So you take 100%, and a decrease insinuates, minus, and then minus 5%, and now we're at 95%. Move the decimal twice to the left, 0.95 is my percent factor. Okay, so these two factors, this is my percent factor, this is the before times percent equals after. But the percent again is in decimal form, 0.95. Okay, we're solving before, so X, and then 2.39. Then we're going to divide, and when you divide, you take the product divided by the one factor, the known factor, 0.95. So 2.39 divided by 0.95 is going to be, remember you're talking money, so we'll go two digits after the decimal, 2.51 or 2.52. I'll accept either answer. Okay, money amounts, I want two decimals. If it ain't a money amount, you can do a whole number.